compound inequalities, okay? First thing we need to talk about, all right? There's going to be a type of notation that I'm going to introduce today, all right? And it's going to kind of fall in line with the open and closed circle stuff that we talked about the other day, okay? If you guys remember, less than and greater than, remember that was open circle, right? Open circle, okay? With this interval notation, and I will get to that, but for interval notation, what you need to understand with interval notation when we get there is less than greater than is going to be associated with parentheses, okay? With parentheses, all right? So less than greater than on a number line is open circle stuff, but when it comes to what we call interval notation, it's kind of a shortened version of you being able to convey answers for these compound inequalities. Open circle stuff, less than greater than, is going to be parentheses, okay? Is going to be parentheses. As far as the or equal to stuff, less than or equal to, greater than or equal to. That was closed circle stuff, right? Closed circle stuff meant, hey, we can include the number that's involved, okay? With interval notation, it's going to be brackets, okay? It's going to be brackets, all right? We need to make this association, okay, with these particular symbols. Less than, greater than, open circle stuff, parentheses, okay, parentheses. Less than or equal to, greater than or equal to, closed circle stuff, and we're going to associate that with brackets, okay, with brackets. All right, I would make sure you jot that down and that we have those things associated with each other, okay? Everybody got it down? Those that chose to get it down? Okay, all right. Compound inequalities, okay? This is where you're going to get two inequalities in one, all right? And we talked a lot the other day about you being able to interpret inequalities not only from left to right, but right to left, okay? Now, I'm going to assume everybody sees two inequality symbols up there, right? You see two inequality symbols, okay? That means we're dealing with a compound inequality. There is a shared variable in the middle there, that x, all right? So, what if I covered that up right there? If I covered that up right there, what is that inequality saying? That inequality is saying x is less than 3, okay? That inequality is describing values less than 3, okay? Now, if I take this and I cover this up, what is this inequality saying? This inequality is describing values that are more than or equal to, greater than or equal to -4. Okay? This inequality, and again, the ability to read these from right to left, I think this is where this is important. This compound look is something that you're going to deal with. Okay? And we need to be able to see it and go, okay, I can get this interpreted if I need to. But that's the tougher one. Reading from right to left. Values greater than or equal to -4. Okay? So collectively, I need to be able to read both of those inequalities, and what is that saying about the solutions? We are talking about numbers that are greater than or equal to -4 and also less than 3. Whoops. Let's say we go to a number line here. Okay? Let's say we put this on a number line. Okay? Just like we graphed it the other day. Less than 3. Would that be an open or closed circle? What would it be? Open. That would be an open circle around 3. And where would you go on that number line to find values less than 3? Left or right? Yeah, absolutely, to the left. If we're talking about values that are greater than or equal to -4, open or closed circle, that would be a closed circle because it's or equal to. And where would you find values that are greater than or equal to -4? To the right or to the left? To the right. Okay? Now, do you guys see where those arrows overlap each other? Where those arrows overlap each other, that's where the solutions are that satisfy both inequalities. We are looking for numbers that not only are less than 3, we're also looking for numbers that are also greater than or equal to -4. Where are those numbers? Those numbers are right here. Okay? That's where the numbers are that satisfy both inequalities. Okay? And that's kind of the dealio with these compound inequalities is they've got to meet a couple of conditions, so to speak. Okay? Values that are less than 3 and greater than or equal to -4. Okay? It would be like me telling you, you will make an A in the class if you will go to the vending machine and get me a Coke and a Dr. Pepper. If you just bring back a Coke, do you get the A? Nope. If you just bring back the Dr. Pepper, do you get the A? Nope. If you bring them both, you meet both conditions, you get the A. That's kind of what's going on here. Values less than 3 and greater than or equal to -4. Okay? So now watch this. Interval notation. We're going to write this answer in interval notation. All right? And remember what I said. Greater than or equal to is a bracket. So we're going to put a bracket around -4. And less than is a parenthesis. We're going to put a comma. We're going to put a 3. We're going to put a parenthesis around 3. That right there, that is the interval notation for these solutions. Okay? The bracket around -4 tells me that's a closed circle around -4. That means I can include -4. And then I go over here to the other side to 3, and it was just less than, so I'm going to put a parenthesis there and say, hey, around 3, that would be an open circle. So everything in between -4 and 3 is a solution. I can include -4. I cannot include 3 because of the open circle. But that would be the interval notation for that solution set, bless you, that solution set of answers. Bless you. Okay? All right. Questions thus far? So check this out. Whoops. Okay. All right. So let's go right here. Okay? Let's take a look at a few of these here. And I've still got my block here. So let's take a look. Let's take a look at this first one. Okay? And I'm going to run this up here. We'll cover that up. What is that inequality saying right here? X is less than or equal to 8. less than or equal to 8. And what's that one saying? X is greater than negative 3. Okay? This inequality is describing values that are less than or equal to 8 and greater than negative 3. Okay? So, if we write this answer in interval notation, is the negative 3 going to have a parenthesis or a bracket around it? A parenthesis around negative 3, comma, there's our 8. Will there be a bracket or a parenthesis around the 8? Bracket. Or equal to is bracket. Not an or equal to, it's going to be a parenthesis. There's the interval notation for those solutions. We're talking about every number in between negative 3 and positive 8. You can include 8, but we cannot include negative 3 because that would be the open circle. Okay? We okay with that? Okay. Interval notation is just kind of a condensed way that I can look and interpret what the solution set of that compound inequality is. Okay? Take a look at the next one. What's that inequality saying? Values that are less than 12 and values that are greater than or equal to 1. Okay? Values that are less than 12 and greater than or equal to 1. Okay? So, we can go ahead and do that if you want. We can go 1 comma 12, parenthesis or bracket around the 1. Bracket, because it's or equal to. Bracket, because it's or equal to. Parenthesis or bracket around the 12. Say again? Parenthesis around the 12 because it's less than. Interval notation, okay? It's still open and closed circle stuff. We're just using some different symbols to represent those types of things, okay? And instead of having to put it on a number line, I can express it in interval notation. All right, let's look at this last one here. What is that inequality saying? Values that are greater than negative 6. Remember, you're reading this from right to left, okay? The alligator opens to the bigger thing. Values that are greater than negative 6 and values that are less than 3. Okay, so here we go. Interval notation. Let's go negative 6 and 3. Parenthesis or bracket around the negative 6. Yep, parenthesis. Parenthesis or bracket around the 3. Parenthesis. There's not an or equal to here. So therefore, I'm not going to use any brackets. They're both going to be parentheses. Okay? That's why we need to make that association. Okay? Less than, greater than is parenthesis stuff. The or equal to stuff is bracket stuff. Okay? So hopefully we find that maybe a little bit easier than having to graph them and draw arrows and shade common areas and all that kind of stuff. We can just express it as interval notation, but we need to be able to interpret that notation. Every number in between negative 6 and 3, not including negative 6 and 3. Parentheses say open circle, do not include. Okay? So far, so good? There we go. Yeah? Awesome. Awesome. Okay, so let's go the other way this time. I'm going to give you the interval notation, we're going to write the inequality now. Okay? So, what we can do, I got it. What we can do, now, if we're going to write a compound inequality for these interval notations, okay? Starting out, I'm going to put an x there, I'm going to put a 2 on the left and a 5 on the right, okay? Now, we're talking about everything in between 2 and 5. Now, there is a parenthesis around the 2. What kind of a symbol do I need right there? Going from right to left, that symbol's going to read, though. How's it going to read? Greater than? It's a parenthesis, so it's not going to be an or equal to. So we've got values greater than 2. What's that next symbol going to be? Say again? Less than or equal to. Correct. Good. There's a bracket. There's a bracket around the 5, so that is definitely going to be an or equal to. Okay? But we're talking about numbers between 2 and 5, so it's got to be values that are greater than 2, hence the parenthesis, and less than or equal to positive 5, hence the bracket. Okay? All right, let's go to the next one. Let's do another one. I think I'd put my x there. Let's put a -4. Let's put a 3. As we know that we're between -4 and 3 here. Now, bracket around -4. So what symbol are we going to put between that x and that -4? X is going to be greater than or equal to. As we read it from the letter to the number, from the variable to the number, this is going to be a greater than or equal to symbol. That is describing values greater than or equal to -4. And values that are, now there's a parenthesis around the 3, so what symbol do we need now? I think I heard it. Less than. Values that are greater than or equal to -4 and values that are less than 3. Okay? Any questions with those two? All right, look at this next one, okay? A little bit different, okay? Now, what this is telling us here is that, and I'm going to graph this one for you, okay? I'm going to show you on a graph what's going on with this one before we write the inequality. Okay? Now, this right here, okay? You see this right here? That is negative infinity. That is negative infinity. Okay? Negative infinity. Now, which way would you go on a number line to go in a negative direction? Left. Okay? So, what negative infinity is telling us is that the solutions are going to go left forever. They're going to go towards the negative side of the number line forever. Okay? Now, where is that coming from? Well, that's where this 6 comes into play. Parenthesis around the 6. So, would that be an open or closed circle around 6? It'd be open. Okay? So, here's what the graph of this looks like. It'd be an open circle around 6, and then we are headed towards negative infinity. Every number from 6 not including 6, all the way to the left, all the way to negative infinity is where all the solutions are, okay? There's the inequality. Guys, we're talking about all numbers that are less than positive 6. All numbers that are less than positive 6. That negative infinity just tells you that it doesn't have a stopping point on the left. Okay? It goes that way forever and ever. Parenthesis around the 6, open circle around 6, and we're headed left. That's all values less than 6. Okay?
So it's literally, it just doesn't go there. There's just nothing there. It just goes straight.
It just keeps going left forever. Hence, negative infinity. The infinity tells you that it is going on forever. It's never going to stop. The negative tells you that it's headed in a negative direction, which is left. Okay? Whereas up here, guys, up here, you had a stopping point on the right and a stopping point on the left. You had numbers on both ends. We had a 2 and a 5. We had a negative 4 and a 3. We had stopping points on both sides, okay? That negative infinity tells you, hey, it's going left forever. Now, look at the next one. Which way is this one headed forever? It's headed to the right forever because we see positive infinity on the right side, okay? So again, if we go to a number line here and we try to get a visual of what's going on, would there be an open or closed circle around the 2? Why? What closes the circle? What's showing you that it's a closed circle? Because what? Why is it a closed circle? The bracket. The bracket around the 2. That bracket right there tells you that is a closed circle around 2.
Yeah, I was right though.
And positive infinity tells us which way are we going. Which way are we going to go in a positive direction forever? To the right.
At least that was correct.
Okay? So as far as an inequality, what is this thing describing? This thing is describing values that are greater than or equal to 2 forever. Values that are greater than or equal to 2 forever. Okay? We just need to know and understand, what does this notation mean? What are they trying to tell me with what I'm looking at? Okay? Okay? Questions? I'd make sure you have that down. You need that reference material there. Okay? All right. So far, so good? Okay. All right. Jot that down. Okay. Let's take a look at this. Now, again, I'm assuming everybody sees 2 inequality symbols. We've got one there, we've got one there. That means we are dealing with a compound inequality. This is a 2-for-1 deal, okay? I need you to look right in between here. Now notice, between those inequality symbols, there's just not a variable. It's not just an x, or an h, or an s, or whatever, okay? We have an expression, 2x plus 3. Okay? Guys, we've got to solve this one. Okay? Kind of like we did with inequalities the other day. We've got to solve this one, but we've got to solve 2 sides to this thing. Okay? And what's going to go on here is we have this one to solve, and we have this one to solve. The 2x plus 3 is going to get shared with both of these. Okay?
That scares me.
Pardon?
That scares me.
Don't let it scare you. Okay? We are going to solve both of these. Now, the good news is that both sides of this thing are we're going to follow the same solving steps for both sides. Okay? So, let me do this. Let me cover that up. If you were going to solve this inequality, what would you do first? We'd subtract 3 from both sides. We would subtract 3 from both sides. And that would be 2x is less than or equal to 4.
Wait, what?
Subtract 3 from both sides.
No. Wait.
Divide by 2. Now, remember, we multiply or divide with a negative anytime we flip the inequality. We are dividing with a positive number here. The inequality will stay the same. So x is less than or equal to 2. Okay? So that essentially takes care of the right side of this inequality. Okay? Pretty straightforward. 2-step solve. Subtract 3, divide by 2. Works out pretty nice. Got a nice clean answer. Okay? So now what we're going to do is we're going to cover this up. Guys, it's the same solving steps. We are still going to subtract 3 from both sides. 3's go away. What's negative 3 minus 3? What is that, negative 6? We're still subtracting 3 from both sides here. We're just working two sides of this thing. And we're still dividing by 2. We're dividing by positive 2. The inequality stays the same because we're dividing with a positive. What's negative 6 divided by 2? Negative 3. Okay? All right? Now, here's your compound inequality. You've got two sets of answers going on. We've got values that are less than or equal to 2, and we've got values that are greater than negative 3. Okay? So a couple things here. One, okay, if you were solving this, and let's say this was like a multiple choice kind of assessment or something like that, and you're looking for answers, here's what your answer would look like. I would probably be looking for this. They're probably going to write it in that compound look using one variable. X is greater than negative 3 and less than or equal to 2. If I want to write it in interval notation, would there be a parenthesis around the negative 3 or a bracket? Parenthesis. What about the 2? Absolutely. So there would be the interval notation of that same solution set. Okay? But the compound inequality, it's a 2-for-1 deal. You've got two inequalities in one. Okay? We're going to solve both sides the same. It gets the same solving steps. Subtract 3, divide by 2, got it. Subtract 3, divide by 2, got it. Okay? But you've got two sets of answers to consider. We're talking about all numbers greater than negative 3 and all the numbers less than or equal to 2. So everything in between there. Can't include negative 3, but you could include the positive 2. Okay? All right, questions here? All right, let's look at one more here. Again, stating the obvious here, we should see two inequality symbols. You see two inequality symbols, you're dealing with a compound inequality, okay? Take a look at what's in the middle there, okay? That middle expression, in this case it's 5x minus 3, that is going to be shared by both inequalities, okay? What do you think we would do first? What would you do first? Let me cover that up. What would you do first to start solving this? Add 3. Add 3. Okay? So what we'll do here is we're going to add 3 to both sides of this thing. Boom. Gone. Over here we got a 5. And over here we've got a 20. The solving steps are going to be the same for both sides. What's the solving step now? What's the last step? How do we get rid of the 5? Divide by 5. Divide by a positive 5. Dividing with a positive number, the inequalities are going to stay the same. 20 divided by 5 is what? 4. And 5 divided by 5 is 1. Okay? There's the compound inequality that's describing my solutions. Values that are less than 4 and values that are greater than or equal to positive 1. If I was going to write this in an interval notation, bracket or parenthesis around the 1? Bracket, because that's an or equal to. That's right there. Parenthesis or bracket around the 4? There you go. It's less than, so it gets a parenthesis. But again, that value in being able to interpret these inequalities, not only from left to right, but from right to left. We really need to be able to do both and have an understanding of what that inequality is telling us about the numbers that satisfy these inequality conditions. Any questions here with this one? Okay with that? Solve them both the same. Got it. Thank you. Solve them both the same. Whatever is in between gets shared with both inequalities. If you want to break them apart and make them two separate problems to solve, I mean, that's fine. I've had some students do that. They prefer two separate. Hey, that's fine. If you want to, you could do one problem like that. You could do the other one like that and work them both. If you want to break them into two separate problems and work them separately, great. If you want to kind of do it like we did here on the TV and just kind of work it all at once with stuff on both sides, that's fine. Whatever you're most comfortable with. Question? Sure.